fx into dx. This result can just put us in where c is a point in the interval AB. Okay, where A is less than C is less than B. C is lying between A and B, or C is a point in the interval in the interval AB, or we can say closed interval A limit. But this C is lying in between A and B. Okay, that is the point. Wherever, but it is lying in between A and B. Anywhere it may lie, but or maybe tilted towards A or tilted towards B, doesn't matter. But this is a point lying in this interval A. Then we can say this is equal to this. Let me take now left hand side, right hand side. Let me take right hand side. Sorry. So left hand side, let me take. You know that left hand side is what? It will be fx dx, which is nothing but we know that this is fx limits a to b is fb minus fa. We just check whether this right hand side is also the same. Let me take that. So now right hand side. Right hand side is limits a to c. This is fx into dx plus sign c to a, c to b. The upper limit is b here, c to b, fx into dx. What do we have this? So this is integration is fx. We know that limits are a to c here, plus sign. This is also fx integration of this fx, and the limits are c to b. I'll apply the limits here. First we put the upper limit. This will be fc minus sign lower limit. It is fa plus sign. This is fb minus fc. Now this minus fc and plus fc cancel out. Okay. So this is fb minus fa equal to fb minus fa. What does it mean? It means that if we divide this interval in number of points or in a point in between, if there is a two intervals, there are two intervals here, A to C, C to B, or number of intervals between this can be generalized. Okay, this is institute. Now this point can be generalized. Let me write the generalization of this point. Now this point can be generalized. Now this property can be generalized. Now let me the generalization of this property. The property is generalized. The property of this property is generalized. Is generalized as below. If we take number of points in between A and B, let me take this is A to B fx into dx equal to. If we take, let me take number of points A to A1, this is fx dx. Lower limit is first A, start from A lower limit and end with the last limit upper limit that we will take. But we can take here this limit A1 here. This is A2 here, fx dx. But let me take this is A2, A3, fx dx, plus and so on. And let me take here this is Cn minus 1, or here it is A here, I'm sorry. An minus 1, this is An. So let's An limit fx into dx. And the last limit is An to b fx dx. So this we have divided A to B, lower limit up to upper limit between number of intervals. Now let me find out the values. So suppose this value of this will be, first it is fx, put here limits a to a1 plus again fx integration of this also. This is limits a1 to a2 plus this is again fx limits a to a3 plus and so on. Here it is again fx limits a n minus 1 to a n plus fx limits a n b. Okay, now if I put the limits here, so first limit is f a1 upper limit minus f a lower limit plus f a2 minus f a1 lower limit plus this is f a3 minus f a2 plus and so on plus this is f an minus f a n minus 1 the lower limit, so lower limit and plus fb minus fa and okay, this is the lower limit here last. What do we see here? This is minus fan plus fan cancelled out. Fan with next one will be cancelled out. Fa2 fa2 minus fa2 fa1. Okay, this is fa1 minus fa1 plus fa1. What will be left here? This is minus fa plus fb. All others will be cancelled out. Finally, this value will be fb minus fa. If we divide the interval in number of intervals, number of small intervals, all those points in between will be cancelled out. The values all at all those points, the value of the integral. Okay, in between those intervals or at those different points will be cancelled out, and we have just seen here. So final answer will be the same fb minus f. Okay, so this is general view of or generalization of the same property, that one that we divide into two intervals. Here we are divided into n intervals of number of intervals. Okay, even then the answer will be same fb minus f. This is what the third property is. Now let me take the fourth property. Today I am discussing about properties, on the properties questions. Okay, one or two I can take the questions here, but first I want to finish these. Now property number 4. What is property number 4 say? Okay, now property number 4. Property number 4 is our fourth question. Question number 4 is 0 to a fx dx equal to, okay, this is 0 to a fa minus x into dx. Now it says that this interval is, the value is this much. I mean, if we change, we put this variable a minus x, the upper limit is put here, this is a minus x. Okay, then the value is okay, this question is unchanged. I mean, the value of this can be written like this. If we put the variable as x, subtracting from the lower limit, or even we can put these two limits here, a plus 0 minus x. That is the same thing. Okay, let me just prove it. If I take the right hand side, left hand side, this is known as that if the variable is okay interchange or is replaced by some a minus x upper limit minus the variable, okay, then the value is same. So let me take prove it. Okay, so this answer is, let me take left hand side here. Proof of this is here. I am proving this. Here it is proof. So left hand side is equal to 0 to a. This we know what. Sorry, fa versus fx dx. Sorry, is equal to, this is f x 0 to a. So nothing but f a here. Position f0 minus f0 we can substitute. No problem, global limit. If 0 after substitution of this limit is given, is some value is coming out, so we can put here f0. This is the answer of this question. Let me take the right hand side. If we substitute a minus x equal to t, let me take t here. If for putting, let me take putting a minus x equal to t, then what is minus dx, differentiating it with respect to t, differentiating it with respect to t, we get dx upon dt minus dx upon dt equal to 1. Imply that dx equal to minus dt. Now if I put the limits, change the limits also. So at a, okay, limits, let me check for limits. Now change the limits also. At x equal to a upper limit, a minus a equal to t, or t equal to 0. T equal to 0 here. At x equal to 0, global limit. At x equal to 0, I substitute here 0, t equal to a, implies that t equal to a. So to get here, limits are a to 0. Global limit is this. This means that value. Therefore, 0 to a f a minus x dx, a minus x dx is equal to negative sign because minus dt is there. It is minus dt. So it is a to 0. Limits are a to 0. Lower limit is a, upper limit is 0. So that x equal to a and upper limit is a, then t equal to 0. That means upper limit is 0. But lower limit when x equal to 0, t is a, but we have substituted here 0, t equals to a only. Okay, so this is ft here into dt, because we have substituted a minus x equal to t. Now this can be changed by property. Which property by this? The property number, if minus sign is substituted, then the limits are interchanged. So this minus b to a fx dx is equal to a to b fx dx. So from property number, so this will be equal to a to b, sorry, 0 to a, I'm sorry, it is 0 to a ft into dt. First we have changed the limits. Okay. Now this is equal to, this is by property number, by property, which property is this? By property number 2. By property second property, this we know that we have changed the, because this minus sign is there. So this limits is interchanged. Lower limit becomes upper limit, lower limit becomes upper limit becomes lower limit. Now this is positive. Now this will be equal to 0 to a fx dx. Now we can change the variable also. The variable, change of variable is immaterial. Answer will be same. So this is by property number. First, by property first. By first property, by property first. This we have calculated. So finally, this is the same answer. F equal to, which is nothing but fa. Or we cannot write this limits. Just we say that this equal to this much. Hence left hand side equal to right hand side. We have not to calculate this value. Just write that this equal to this much. Answer is same. And this is equal to same thing here. This is what we have to solve it. So we have obtained the same result. Okay, no need of writing this upper limit. We just say that this is the, we could take only right hand side. No need of taking left hand side. Then we can say that yes, we have obtained the left hand side here. Okay, this is the left hand side by property number first. Okay, so this is property number fourth. We have done. Now let me take fifth question or property number 2. I've written down here all the properties so that in the form of questions I have taken them. But these questions are, as I always say, students have asked me all these properties. I have found in some of the books which we teach, or to which we teach, there are only 5, sometimes 4, sometimes 9 properties only. But here I've taken 11 properties, almost all the properties which students have asked me. Okay, sorry. This is what property we are talking about. Now, which property let me take? Okay. Now, property number fifth question number. What is question number 5 here? Let me talk about property number 5. This is property. Let me write property. Property 5th. Okay, the property number 5th. Or question number 5th here. This is question number 5th. But in question number 5th, it says minus a to a limits are fx dx is equal to 0 or twice 0 to a fx dx. Okay, so this can be written as, let me take the left hand side here. What does it mean? Here let us take the left hand side. We have to prove that this is equal to 0 either or equal to this. So left hand side is minus a fx into dx. Can be written as minus into, let me take 0 in between. This is fx dx plus sine 0 to a fx dx. Can be divided into where 0 is a point lying in between, where 0 is a point. This is by additive property. This is known as additive property. Okay, so additive property. This is by additive property we can see where 0 is, or where minus a is less than c, that is 0 is less than a, or 0 is lying in the interval minus a to plus a. This is minus a to plus a in closed interval, no, not a problem. Can be like this, minus a and plus a. 0 is lying in between. We have taken here open interval. Minus a is less than 0, less than a. Open interval or maybe closed interval. So this in this interval 0 is lying in between minus a and plus a. So this we can write. Now let me talk about this. Okay. Now if I substitute here x equal to minus t, because we can change the, or take the minus sign here also. If I substitute minus sign, okay, so putting, let me take left hand side here minus a to 0. If I just find out this value is equal to minus times that value, so this is minus fx dx. Putting x equal to minus t. Putting x equal to minus t here. What do putting x equal to minus t? You can change the interval, no problem at all. Putting x equal to minus t here. What does it mean? Now, therefore dx equal to minus dt. Therefore, differentiating with respect to t. Differentiating it with respect to t. With respect to t, we get this value dx upon dt equal to minus 1 or dx equal to minus dt. Limits. I put here limits at x equal to 0. At x equal to 0. T equal to 0. Well, if I put here 0, T 0. At x equal to minus a, at x equal to minus a, T equal to plus a. By this minus a here, minus minus cancel out, t equal to plus a. The limits will be a to 0, but with this minus dt, minus sign is there. Here it is a to 0, a to 0 limits. This is ft dt. For this minus dt, I've taken the limits here. I mean this minus sign here. It was minus sign. Okay. Now with this minus sign, the limits can be interchanged. This is equal to 0 to a ft dt by property number 2. By property, this is by property 2. Second property. By second property, you can interchange the limits if minus sign is there. Minus sign is eliminated, so it is 0 to a here, positive value. So this is 0 to a. We can write here fx dx. Why? Change of variable doesn't change the value of the function. So it is by property number third. Sorry, by property number first. This is by property number first. By property first, we have changed the variable here. Now, if this value is equal to positive value, positive is fx positive, or it can be negative if it is odd function. If, let me write here. So we have obtained finally this, the first part of this show is equal to, let me write here, therefore, this is equal to, from this we have obtained 0 to a, this is fx dx. We have proved that this limit is fx dx plus 0 to a fx dx, this second part. This is also 0 to a now. From this we have just proved, taking this first part only. This part we have taken to this one. This has reached up to this result. Now, if this result is the same positive, if this is even function, or the odd and even function I will talk about. If fx is an odd function, if fx is an odd function, what is odd function? Even function. That means, which I have already defined number of times, but let me talk about this. If fx is an odd function, then f minus x, if we replace the variable by minus sign or multiply by minus sign, then it will be equal to minus fx. In case of odd function, the change of variable, if we change the variable with negative sign or put the negative sign before the variable, then the function is changed with negative sign here, because this will be odd function. In case of this fx equal to f minus x equal to minus fx, this is odd function. If fx is an odd function, then this first function will be negative value. So 0 to a fx dx will be equal to 0 to a, okay, f minus x dx, which is equal to minus fx dx, 0 to a fx dx. What do we see? This value we substitute in place of this. It will be minus fx dx, 0 to a limit 0 will be cancelled out 0. Therefore, in that situation, with odd function, then this value equal to 0. Then this, when minus a to plus a, fx dx is equal to 0 to a fx dx plus 0 to a fx dx is equal to minus this sign 0 to a, sorry, 0 to a fx dx. So this is odd function here. First part, this is odd function. So this is the first portion will be negative then. So it will be plus sign 0 to a fx dx. What do we find? This is 0. Okay. These two values are zeros. Alright, this we have obtained here. These are, this is 0 if it is odd function. But if it is even function, then in case of even function, the odd function, even function, as we say that tan x is an odd function, sin x is an odd function, while cos x is even function. Why? Because change of variable to negative sign, okay, is immaterial for cos x. Cos x even function. If it is even function, if fx is an even function, then f minus x equal to positive fx, like cos minus x equal to positive cos x. Cos x is an even function, which is an even function. Even function with negative sign doesn't change, is an even function. Okay, while sin minus x equal to minus sin x, odd function, tan minus x equal to minus tan x, odd function. These two are odd functions. Odd function are mixed with negative sign, the value changes. If we replace the variable x with negative sign, multiply with negative sign, the sign will be, the value will be changed. It will be negative then. But in case of even function, it is positive, doesn't change. It will be positive, then it will be twice of this. So therefore this value minus a2 plus a fx dx equal to, this will be positive, then they will be added up twice, the same value will be added up, it will be twice 0 to a fx dx for even function. This is for even function. We have just checked here for even functions. Okay, so for even function, we talk about this question in this way. This is what property number 5 is there. Okay, now let me talk about the next question. Question number 6, or we say property number 6. Now property number 6, or question number 6 here. What is question number 6? Let me talk about that. Here question number 6 says 0 to 2 says fx dx equal to fx dx equal to twice, it is 2 times 0 to a, okay, fx dx if f 2a minus x equal to fx. If this has been proved that this is equal to this one, you twice of this and equal to 0 and equal to 0 if f 2a minus x equal to minus fx equal to minus fx. If it is odd function, actually this value equal to then, so it will be 0 then in that situation. Now let me talk about this question. So what is this? So left hand side, let me take it also of the similar type, 0 to 2a, this is fx dx, can be written as 0 to a, let me take, this is fx dx. We have taken one point here in between, this is a to 2 fx dx. Okay, so if I take a to 2a, this element here. Okay, now let us take it as, okay, this value is equal to 0. Okay, let me take the second part here. So let us take the second part. second part of this integral okay, that is 0 to a to 2a fx dx. If we substitute x equal to 2a minus x, let's say 2a minus x. Okay. Let us take in place of x. If I replace it by 2a minus x, so let 2a minus x equal to t. Let 2a minus x or 2a minus t, let me take. Let 2a minus t equal to x. But we have substituted in place of x, we have substituted 2a minus x. Or x equal to 2a minus t. Now differentiating it with respect to t. Differentiating it with respect to t. We get, what do we get here? This is dx equal to minus dt. Differentiation. Now for limits, here, let's talk about limits. Okay, at x equal to 2a here, or it can be when x equal to 2a, here 2a, 0, t equal to 0. Okay, so t equal to 0 then. But as x at x equal to, if I put here 2a minus x equal to t, that is also there. T can be for limits when at x equal to, let me write here, x equal to 2a, t equal to 0. T equal to 0. At x equal to 2a, substitute here x equal to, here 2a, we can get out t equal to 0. And if x equal to 0, then t equal to 2. And at x equal to 0, t equal to 2a. The limits are what? It will be 2a to 0. Sorry, I'm putting here limits a. Sorry, at a, not 0. This is at 0, but at a, it is a only. Sorry. At x equal to a, t